Hello, good morning, and bon dia to everyone in Portugal. Thank you so much for joining us today for this webinar of CrowdStrike. We're going to talk about hacking, we're going to talk about container technology, and we're going to talk about very exciting things today. A little bit about myself, so for you guys to get to know me. My name is Alvaro Rodriguez. I'm a Spanish sales engineer based in Spain, very close to you guys. For the last 10 years, I've been working in cybersecurity, specifically very focused on security operations and incident response, but also as well in threat intelligence, helping a bunch of governments to build their CTI programs and operations. Today, we have prepared a really interesting hack demo in where we're gonna challenge a specific container technology in Cryo, and we're gonna see if we're able to escape from the container and then actually get into the underlying host to spread further into the environment. Okay, let's see what we can do here. But first off, a little bit of context before we jump into the vulnerability and the hack. A little bit of context on this attack. So earlier this year in 2022, our cloud threat research team, our CrowdStrike research team, discovered a new vulnerability specifically in Cryo, which is a container runtime engine underpinning Kubernetes. So basically, in a nutshell, this vulnerability, when invoked, allowed an attacker to escape from a Kubernetes container and gain root access to the host, and then be able to obviously move anywhere in the cluster, right? So it's a pretty critical vulnerability. It was actually scored as 8.8 on the CVSS, okay? Again, before we dive into the hack, and I appreciate that most of you guys will be very familiar already with virtual machines and containers, but let's spend a few seconds speaking about the basics, right? So obviously we got virtualization and we got containers, right? What is a bit of the difference, no? If we look at the left, we look at virtual machines. You got a hypervisor, which really emulates the hardware, okay? And then you can run an operating system on top of it, and then you can run any applications you want, okay? The real beauty of hypervisor technology is that it's incredible isolation, right? It's incredible isolation. You've really virtualized, you're really virtualizing the entire machine from the hardware all the way up, right? So from a security perspective, is very robust. Now, if you compare this and contrast that with a container is really focused on virtualizing the application space, okay? As you can see in the diagram here, you have a container engine which runs containers and then ultimately runs the application, right? The container, of course, has everything that you need to actually run the application, like all the necessary libraries as well. And the whole idea with containers is the fact that it makes it super easy and super efficient. But again, the question is at what cost, right? At least in terms of security. And from a security perspective, so if you have a shared host exploit, conceptually speaking, you end up in a situation where a raw container, you know, a malicious container can actually allow an attacker to get access, and they could get full access to the underlying host and then all the containers and the host, right? And now from there, an attacker can obviously set up persistence, can get access to passwords, inject into runtimes, and worst case scenario, even execute ransomware, okay? Let's also spend a minute on Cryo, which is another technology. Is a container runtime engine, no? It is a bit of equivalent for Dockers. And in a nutshell, speaking about containers technology, so you got containers, which is a sort of a bundling of applications and libraries. And then you got pods. You can have one container in a pod, or you can have multiple containers in a pod. And then you have a cluster, which is a group of pods put together. And then you got Kubernetes, which is really the orchestration layer for a bunch of different clusters and pods that are out there. Speaking about CRI-O, it is, as I said earlier, a container runtime engine, which has a lot of, let's say, power and reputation on the open source, and it's actually a community-driven container technology. It's very openly spread, and a bunch of companies and technologies use CRI-O openly, like Red Hat, OpenShift, SUSE, Oracle container engine. So it's a very, very common technology. Let's jump now into the vulnerability details. Okay, and again, credit to our CrowdStrike research team that worked on this. It was a pretty cool research that they found. So again, CRI-O, specifically the 1.19 version, introduced support for syscontrol, which is a common concept within Linux, because it gives you the ability to set kernel options in this specific context to the pod itself. Okay, all of the syscontrol options are passed to a utility called pins. You can use pins because it's a lot easier to set those system controls, right? And it's actually the process that modifies the kernel. What is interesting is that the conversion of syscontrol options into the pins arguments have no validation. And that is obviously, as you will see, a pretty serious situation that doesn't end well as we go through this demo and hack. Okay, let's go into a little bit of more detail. Okay, when you look at the system controls, they're grouped into safe and unsafe system controls, right? All of the safe, obviously, system controls are enabled by default, and the unsafe system controls are disabled by default. But here's the problem. CRI-O validates the Kubernetes syscontrol names against a set of known safe options, but it doesn't actually check, in this instance, the actual value, meaning the values of the fields themselves. You can see that on blue, highlighted in blue here on the screenshot, right? So unfortunately, we're talking again about a classic, perhaps 20 years old common input validation error, but now transported into the containers world. Let's see how it works more in detail, right? You can see here, highlighted in blue, that this section hasn't been validated, right? It checks the name, so we can see kernel.shm forced, right? But we actually dropped in a value using the plus character kernel core platform, right? You can see 1 plus kernel.core dash pattern, right? And this is where the problem resides. You can actually add multiple kernel parameters that go unchecked, they go unvalidated, right? Now, obviously, for adding kernel parameters, we can do things with nefarious purposes, and we're going to show you that as part of the hack later. But before jumping into the hack, I would like to talk a little bit about this core dump concept and how they come into play with this particular issue, right? Let's go back to the previous slide for a sec. So core dump, very common concept that obviously most people are very familiar. It basically creates a file in a normal situation, right? When the Linux kernel or program crashes, the kernel core parameter tells the kernel how to create the file, right? And this text file has all the information about what caused the particular crash. Now, what's really simple about this technique is that you can use CRI-O and the pins utility to effectively tell the core kernel that instead of creating a text file, and writing the output to the text file, where there is a core dump, of course, you can ask the kernel to execute a script. And then obviously, if you can get a privileged process to run, which happens when you have a core dump, you can execute the scripts with the privilege that you need to actually hack the machine, right? So there's a lot of things that may seem new in terms of Kubernetes and clusters for all of us, but you know, new is old, and still the oldies, but the goodies work in just like new environments like cloud, right? So now, what is next, right? So how you would be wondering now what an adversary, an attacker can do at this point, right? So if you get access to the underlying host, it's pretty much game over, right? That's ultimately what you want. Is to just get to that root access, right? You can infect and inject all the processes into the containers. You can launch new malicious containers, get credentials, and again, just about any incident response that CrowdStrike has ever done, we've seen like some level of credential theft and lateral movement, right? This is why we insist so much that identity protection and identity controls are so important, right? So, and this is the last one, which we're seeing more and more is cloud-based ransomware, right? This is the ability to actually just take out of a production environment, including obviously all the cloud technology, right? This has a lot of impact and tends to force people and companies to pay a lot of money to get back the environment up and running, unfortunately. Let's get now into the actual hack, okay? I will show you a number of screenshots to showcase the hack now, right? First, as you see, we've used Minikube here to set up the environment, okay? Minikube is a tool, it's an implementation tool that lets you set up the Kubernetes environment locally, right? So it makes it a lot easier to demonstrate this, right? You can see here, highlighted in red, the demonstration version is 1.22.1, which is one of the vulnerable versions. So what I'm going to do here is I'm going to just pivot very quickly to show one of the pods in our environment, okay? Let's have a look at the pod configuration here, right? There is a modified version of a standard image, right? You see there, mistaken container. How does this come out, right? How does it work? There's a couple of different ways that this can happen. As I said earlier at the start, you got hundreds and hundreds of repositories of containers that you can just download, right? If you do a bit of search, you can just find a container to do almost anything pretty straightforward. Typically, attackers can do something like super basic here. For instance, using some sort of type of querying technique, they can just set up a site and put a couple of row of malicious containers in there, okay? And this also goes back to the supply chain issue, right? If somebody can just tamper with a public container that's out there, it is a little different than tampering with the source code, but it has the same effect, right? You're getting a malicious object in your environment that can run with elevated privileges. So let's just launch the container, right? And we're going to look at a little bit about the insights of this container, right? You're going to use kube control or kubectl. Let's run the pod with that modified rogue image, right? So a straightforward process to get it up and running there, right? As we can see. What I want you to actually do now is I want to shell into the box itself, into the container itself, and just run a basic ls command to see what is actually running inside that container, right? And we can see here that we dropped a file, you see highlighted in red, a file in here with the malicious script, right? Malicious script. We haven't got very creative for that name. And now this becomes a little bit more interesting, right? The next thing we need to gather is the path to the particular malicious script, right? Residing on the raw container. It is very easy to get that command or to get that particular location, right? If you're not familiar, all of the containers, we have a numeric value, right? You get the numeric value and then the location of the script. And basically at this point, we're pretty much ready to go, right? And then let's just pivot to another container. You should notice a couple of things that we talked about earlier. And I will just highlight it here for everybody, okay? This is where the issue comes into play. We got the name here, syscontrol. We got the name here perfectly fine, right? It's validated. It's a safe command. You can see there, no? Kernel.shm dash r meet dash forced, right? The issue is that the value itself, right? As we explained earlier on the theory part, the value itself, you notice, yes, underneath, we dropped in the plus kernel pattern, and then the full path to that malicious script, right? And then that goes entirely unvalidated. It goes unchecked by the system, right? That parameter will be passed, and it will be run with absolutely zero validation. Moving along here on the demonstration, we just want now to set up a situation where we're going to cause a core dump, right? That would trigger the script, right? This is a very, very trivial thing to do. Now, the one thing that I just want to talk about is to do it. All we need to do is effectively a basic segmentation violation, right? If you are connected to the cloud, if this were a container with cloud access, again, very trivial. Now, for demo purposes, I'm gonna just run it obviously on the local host machine, just to simplify. And we're gonna do a segmentation violation. We've triggered a core dump. What's happening in the background is, remember that we are no longer executing a text file with a core dump, but this malicious script, right? And what you can see here from Netscat is that we got a connection back to the attacker. Let me go to the next slide. We go to the connection back to the attacker, and then we can see that we are running as a root. You see it on the upper left side. We can see that the host name is minikube. We dropped into the underlying host, and then at this point we are also listing all the containers running, as you can see. And at this point, this is game over, right? What we can see here is all the containers that are actually running. And if you're thinking that looks really simple, it's really simple, right? There was nothing about that was really hard, other than the fact that we found the vulnerability without the validation, right? And for everybody running containers, this is very real scenario that play out, like I said, a vulnerability with a risk score of A.A, right? All right. In terms of recommendations and best practices, right? I'm gonna first focus on detections and then also on preventions, right? The first thing that I like to say, and I think this is hopefully basic or very common for everybody, is to monitor all unexpected activities, right? Whether it's a traditional endpoint, it's a virtualized machine or a container, this boils down to the concept of EDR, right? It's just looking for unexpected activity, right? Programs that you don't expect to run, container images that come from registries that you don't know, entirely new images, like in this case, weird configuration options. There should be things that you're programmatically looking and hunting for, okay? When it comes to prevention, obviously, I mean, it's the same thing that the security industry keeps pushing, right? Patch, right? We can say that enough, right? The question is that you will be asking, what do we do if there's no patch, right? What do we do if you can get a patch out in time, right? Well, obviously, you need to do things like minimize the attack surface to limit anyone trying to expose that, right? Speaking about preventions and patching and mitigations, we've got a whole blog on this that we're going to share after the webinar. Okay, so we're not going to spend too much time on this, right? But I honestly recommend everyone to have a look at this blog post because it's very comprehensive. But this is a really important point, right? You can focus just on the containers. You have to focus also on their underlying infrastructure, on the host itself, right? You have to have a whole coverage. And then the other one here, which is like this common concept of shift left, right? This is basically the classic concept of having a robust container software, or like a software development lifecycle security, right? Doing things like image scanning, doing things like pod scanning, implementing image signing to make sure that you don't have rogue or malicious images, making sure that users cannot publish images directly to the production registry. So this is basic 101 blocking and tackling, right? It's as simple as that, okay? This was the purpose of this webinar was to cover more on the technical side, right? But obviously, we appreciate that some of you aren't necessarily comfortable with all these commands and all these preventions, right? The only thing that we want to show you today is that everything that we cover now in terms of preventions and remediations could be obviously automatically executed, right? With a product, no? In this case, with a cloud container product or a cloud workload protection product, right? This is actually something that we are obviously very happy to share with you, right? In this case, this is our detection capability that shows the attack technique. In this case, is highlighting the pins utility. And then on the prevention side, we also have the ability to showcase all potential risks and like exposures and attack surface that could be leveraged by an attacker, right? In this case, the CTL configuration, right? Very happy to show you this in a demo, to run a POV, but let's move on, okay? In summary, okay, let's summarize a little bit, right? So containerized workloads and orchestration systems like Kubernetes, certainly they're here to stay, and they're going to stay. In our opinion, is the future and obviously the present. We at CrowdStrike, we continue to build our technology based on these environments and these systems. But security is complex, and it's really complex because it has to parallel the slope of the technology curve, right? So at the end of the day, and as a community, we really just need to focus on, again, defense in depth, right? The proactive controls, which we talk about, need to be able to prevent that supply chain attack, those third-party software from running, okay? So when you think about DevOps and DevSecOps, and we have a whole bunch of releases on a daily basis, right? It's really crazy how fast it goes. You got to be able to make sure that you got fast patching, right? That you're updating your containers, that you're running a robust runtime configuration, monitoring technology, and being able to automatically remediate this in almost near real time, okay? Because you got to keep everything up and running from a production environment, okay? And finally, it is also about looking and detecting and preventing unexpected applications, okay? It's about looking to understand what is your environment, and it's looking to patch as soon as you possibly can, okay? All the things that I like to back it down as just security, good security hygiene, okay? There's no difference in a container wall. And that's really what the takeaway was that we wanted to sort of impart on everybody, okay? A lot of serious impacts on this particular vulnerability can be very easily mitigated from a technology perspective with the right tools and the right processes, okay? Thank you very much to all of you guys to attend this webinar. We're very happy to attend any questions and clarifications, and we hope to see you guys very soon.